So hello again everybody, I am Radu Horoiu, Professional Services Engineer at Infinet Wireless. Thank you very much for joining the webinar. Today I will make a roundup of the most important updates that have been made recently to the R5000 and XG platforms. I will begin by showing you the main updates of the R5000 platform, which are the combined mode of the spectrum analyzer, the mass firmware upgrade, which is performed over the air, the Ssl certificates, the on-demand routing configuration, which now can be performed more easily using the web GUI, the Mint failover option, which I have presented in more detail during the previous webinar, and the improved route map tool. Then I will move on to the XG main updates, which are the ATPC, the RF Link Authentication, the automatic uplink downlink ratio, the RF setting export to the other end of the link, which is also done automatically, the link availability statistics, and the instant DFS. As I mentioned earlier, I will start with the R5000 platform, and the first important update that I want to show you is the combined mode of the spectrum analyzer, available since software version 1.90.28. This new mode, which you can easily enable in the spectrum analyzer section of the main menu, which you are familiar with, allows you to start the spectrum scan on all connected units, including the local device. After the scan is finished, you must click the last snapshot button to display a superposed image that contains all the spectrum information from all the connected devices. The combined mode is especially useful in case of point-to-multipoint topologies. When you have multiple CPEs in a sector, you just have to start the scan only from the base station, and you will get a combined picture that shows the interference levels in your whole network. Thus, the combined mode greatly simplifies the scan process when compared with the local mode. As you can see in this slide, the local mode, in the local mode you must perform the scan for each unit one by one, and then compare the pictures side by side, which can be very cumbersome, especially in case of large point-to-multipoint networks. The next very important update of the R5000 platform is the over-the-air mass firmware upgrade, available since firmware 1.90.27. This feature enables you to perform firmware upgrades to all the Infinet devices in your network much more easily than before. You just have to go to the maintenance section of any Infinet device, choose a firmware file that you have previously downloaded from our FTP server, check the OTA box like you see in the picture, and then click the upload button. The new firmware will be installed automatically on all devices that are in the same mint area and that also match the hardware platform for which the file was created. In case you have multiple hardware platforms in your network, you must perform the mass upgrade for each platform in turns. Again, this can be done from any Infinet unit in your network as long as you have a single mint area, and it is also important to mention that the firmware will not be applied to the local unit from which the upgrade is being initiated. It will be installed only on other units in the network. If you want to upgrade only the neighbor devices of the unit, you can do this by checking the neighbors only box, as you can see in the picture. This means that the new firmware will be applied only to the units that are directly linked to the local unit through a radio connection. And after you have initiated the upgrade, you can check the progress for each device in the system log, which is available in the device status window. Once the upgrade is complete, the target units will be automatically restarted and the links will be reestablished. The whole process lasts only for a few minutes, and the actual downtime will be only 35 to 40 seconds per device, just as with a regular firmware update. Another update brought recently to the R5000 family since version 1.90.28 is the ability to use Ssl certificates. As you can see in the picture, by clicking the link that you find in the maintenance window, you can download the Infinet Wireless self-signed certificate. This allows you to upgrade the software version of the unit when you use HTTPS to connect to the web interface. You can also create your own SSL certificate with RSA private key in PEM format that complies with your specific security standards, and you can upload it into the Infinet unit, as you can also see in this screenshot. Next, I want to talk about the ODR, which can now be configured much more easily via the web interface since version 1.90.29, which is the latest Mint firmware release. First, I must mention that on-demand routing, or ODR, is a structure of the Mint protocol. It provides dynamic routing capabilities in stub networks without the use of any routing protocol. The main advantage of using ODR is the increase of the available bandwidth for your network, which is achievable by eliminating the service traffic of a separate routing protocol while still maintaining dynamic routing functionality. The ODR protocol propagates IP prefixes on the layer 2 using the Mint protocol. The downside is that ODR is applicable only to stub networks of the hub and spoke topology. In the picture, you have an example of such a simple point-to-multipoint network where each subscriber or spoke is connected to a base station or hub, which in its turn is connected to the default gateway. The configuration of ODR is extremely simple. You just have to go to link settings on each Infinet device in your network and set it as hub or spoke, as you can see in this slide. Next, we have the Mint Failover option, which is also available since version 1.90.29. And it allows you to configure the standby mode for backup links in a 1+1 configuration. Both links can use the same operating frequency. The main link can be any kind of wired or wireless connection, but the backup link must be an R5000 link, because the failover mechanism is based on the Mint protocol, which is only supported by the R5000 family. I will not go into more details about this feature because the topic has been fully covered during the previous webinar. So in case you missed it, please watch the recording, which is available on our YouTube channel and on the Infinet Wireless website. As you can see, I have also included the link to the video in this presentation to make it easier for you to find it. And the last update that I want to show you is the improved route map tool. The route map has been available for a long time, but with the latest firmware update, it has been upgraded to provide more information and functions. There are some color indicators that help you distinguish between the different types of connections that you have in your network. So the blue arrows represent the radio connections between your units, the green arrows indicate PRF connections, and the orange arrows show the Mint joins that you have created between various Infinet devices. As the traffic carried out through a link increases, the arrow becomes thicker, indicating the total traffic load. By moving the cursor over a link or node, you can view additional information about each object on the map, like bit rates, distance, load, uptime, MAC address, and so on. If you have a lot of devices in your network, the route map can become very cluttered, especially because in the default view, the objects are not fixed. Instead, they are allowed to float around on the map. By using the click and hold function, you can lock the devices into position or move them to a desired location in order to better organize your nodes so you can have a clearer view of the whole network. The route map tool is based on the Mint protocol. This means that you must have a single Mint area in order to display all Infinet devices in your network. But the benefit is that you can manage any of the other devices from the local unit using remote commands. You just have to double click on any of the devices on the map and you will have access to the CLI interface of that unit. Moving on to the main updates of the XG platform, and the first update that I want to show you is the Automatic Transmit Power Control, or ATPC. As you probably know, the XG didn't have ATPC at launch, so this important feature was brought along with the 1.7.0 software version, which was officially released last year in June. When ATPC is enabled, it works with the target RSSI setting to adjust the power of both units. Besides its own transmit power, the master unit also manages the transmit power of the slave unit in order to achieve the target RSSI value of its own receiver. The slave unit only follows the directions of the master and adjusts its transmit power according to the received indications from the master. RF Link Authentication was also a necessary update for the XG platform in order to increase security. You can now configure a secret keyword for encoding the protocol messages, which can be up to 64 characters long, and obviously it must be the same at both ends of the link. The uplink-downlink ratio now has an automatic setting, which means that the time subframes can be allocated dynamically depending on the amount of data that needs to be transmitted in each direction. It is very important to mention though that in case of synchronized sites, you must not use the automatic uplink-downlink setting, because if you do so, obviously the synchronization will be compromised. In case of synchronized sites, the uplink-downlink ratio must be fixed and identical for all synced devices. Next, I want to show you one of the most interesting and extremely useful features brought to the XG platform, which is the ability to export radio settings to the other unit of the link automatically. It works like this. If at one end of the link you change one of the radio parameters that must be the same at both ends, you can export the same settings to the other unit as well, so you don't lose the connection. In other words, if you want to change the frequency, frame period, or any other radio parameter, you can do it from one side of the link, and the setting will be applied to both sides automatically. This feature works for both master and slave units. As you can see in the picture, when you change these radio parameters, some visual indicators will appear. The blue icon indicates that the respective parameter will be exported to the other unit, to the other end of the link, while the orange icon indicates that changing that parameter will require a link restart. Moreover, if you are not sure about the effect of the new configuration, you can enable the safe mode by checking the safe mode box in the lower left corner of the web page. This will automatically restore the previous configuration after 10 minutes in case the link has not been re-established or if the link availability is less than 80%. So regardless of what parameters you change, if you use the safe mode, you cannot lose the connection. As I said, in case something goes wrong, the previous configuration will be restored within 10 minutes. That's the worst thing that can happen. The link availability statistics are also present since version 1.7.0 of the XG firmware. As you can see in the screenshot, you can use the Show Availability Statistics button, which is located in the status window, to display the link and MCS availability. The statistics are displayed for the vertical and horizontal polarized streams at each modulation and for both sides of the link. And the last important update of the XG platform is the instant DFS functionality, which was also introduced in software version 1.7.0 for the 5 GHz XG devices. First, I must mention that the instant DFS can be enabled only on the master unit in the radio settings section, as you can see in this slide. Then the Instant DFS tool allows you to visualize the Instant DFS graphs that show the average and maximum RSSI and detailed RSSI versus frequency information for all the available channels at both the local and the remote unit. The first graph shows a blue and the green line that represent the maximum and average RSSI at each frequency for the selected master or slave unit and vertical or horizontal polarizations. You can select points on the graph in order to view the exact RSSI values like you can see in this picture. In the next slide, we have the detailed graph which shows the RSSI values for both the vertical and horizontal polarizations. As you saw earlier, there are two of these graphs, one for the local and one for the remote unit. Here I'm showing only one graph as an example. Besides the RSSI bars, there are some colored indicators that show which are the active channels on the uplink and downlink, what channels are ready to switch to the active state. The channels undergoing CAC are also highlighted using a very light yellow tint, which I hope you can see in the picture. And the NOL channels are marked as well, showing that those frequencies are not allowed to be used because of radar detections. And if you click on a channel on the graph, a little window will appear, as you can see in this example, which shows all the relevant parameters for that channel, like frequency, average and maximum RSSI, uptime, transport block error ratio, NOL timeout, or CAC remaining time. This brings us to the end of today's webinar. If you have any questions related to the topic, please write them down in the chat section and I will answer them one by one. Thank you. And I see there are a few questions already. So we have a question: is OTA firmware upgrade installed on all radios in the same subnet? Upgrade packet broadcasts to other Infinet units. Yeah, so the OTA firmware upgrade is based on the Mint set of protocols. So if you have the same Mint area, the firmware will be applied on any matching unit in that Mint area. It doesn't have anything to do with subnet. It could be the same subnet or different subnets. It doesn't matter. All that matters is for you to have the same Mint network. The same Mint network means that you have, for example, a base station and multiple CPEs. They are connected using Mint because they have direct radio connection, but also you can create PRF interfaces in order to extend the Mint network over Ethernet networks, like I showed you in this presentation. There I had some just a second to roll back to that slide. I had some PRF interfaces as well. Just a second. Yeah, here in this network, actually I'll use this as an example. So here I have unified the Mint network because I created the PRF interface at base station 1 and at PTP master. So the Mint packets are allowed to travel now between BS1 and PTP master. This means that if I want to upgrade, for example, the PTP master and PTP slave, in this example, that are hardware 07 devices, I can do this from any other node in the network. So for example, I can go to CPU1, upload the firmware for H07 for hardware version 7 for PTP master and PTP slave, and I can check OTA on CPU1, and the firmware will be applied to PTP master and PTP slave, no problem. But this is only because I have created these PRF interfaces and joined between them, between BS1 and PTP master. So I hope this answers the question. The OTA firmware is based on the Mint protocol, so you must have a unified Mint area in your network in order to be able to export the firmware to distant devices. The next question: is it possible to have a route map tool, the route map tool, to show separate PTP links which have not been joined into one Mint network? No, this is not possible. The route map only shows the devices that have been joined using PRF interfaces, or the PTP, the PT point-to-multipoint networks, let's call them, which are obviously connected directly. The CPs are connected directly to the base station. Okay, so yeah, to conclude this, you cannot see all the devices in the route map, all the devices in your network, if they are not in the same Mint area. You can only see the devices that are in the same Mint area as the device to which you are connected directly, from where you open the route map. Okay, next question. For R5000 and XG update firmware, is it possible the new firmware work with old firmware? No, we do not recommend this. So generally we recommend you to use the latest firmware for all your devices, and the exact same firmware version must be applied at both ends of the unit. So it is possible for them to work in some situations, but it's not recommended at all. We recommend to put the same firmware version at both ends of the link. The next question: what is NOL? Just a second to move right there, where I think it is explained. Yeah, NOL means non-occupancy, and it means that when a radar is detected on a channel, that channel will be blocked from usage. It will be off for something like 30 minutes. The unit will not be allowed to, the unit will not be allowed to use that channel for about 30 minutes. So that's what it means, non-occupancy timeout. That is what NOL means. ODR, the next question, ODR equals LACP? No, there are totally different things. LACP means the Link Aggregation Control Protocol, and it has nothing to do with ODR. The next question, so OTA cannot upgrade separate PTP links in separate mint areas? Yeah, unfortunately not. You cannot use OTA with different mint areas. You can create joins at least for a short period. If you do not want joins there, you can create them only for a short period when you make the upgrades in your whole network in order to do it more easily, and then you can remove the joins afterwards. Okay, next question. For the live existing networks with old firmware, how to implement migration to the newest firmware? The easiest way is to create a single mint area in your network, to join all your devices, all your mint areas, and you can do it from only one place. And from there you can upgrade the firmware to your whole network. Obviously, as I said, as I mentioned in the webinar, if you have different hardware platforms, different devices, you have to do it a few times, once for every hardware revision that you have in your network. But you only have to do it once for one hardware type. If you cannot create mint areas, a single mint area, if you cannot join your mint areas into one single mint domain, then you have to do it for each individual mint area one by one. This is the only way. But it also it helps you anyway, even if you, especially in point to multi-point topologies. For example, a base station and all the CPEs that are connected to it are automatically in the same mint domain, so you can upgrade all the CPEs at once from the base station. You can upload the firmware on the base station, click upload, check OTA, click upload, and from there on everything is done automatically. So yeah, in case of point-to-point topologies, you cannot you don't get a major advantage by using OTA, only if you are able to join your mint areas. And again, as I said earlier, you can create the joins just for a short period of time and to do the upgrades, and then you can remove the joins afterwards. It's much easier. If you have a lot of devices, it's much easier than upgrading manually each link one by one. So I see that there are no more questions. Thank you all once again for your time, and I hope to see you again during our next webinar, which will probably be next month. Thank you. Thanks again, guys. Goodbye.